AP Econ, AP Eco.
No, AP Calc PC is the only AP test I didn't pass.
All right, guys.
I took my AP Physics C and I the shit out of it. I figured I like it too.
Everybody. I know you're not done, and apparently I don't care. I'm just going to start going this over with you. I want to ask you first thing, even if you haven't really done all of them yet. Which problem was the worst?
Number 4.
I knew people were going to say all of them. Number 4? Okay.
4 and 2B.
2B? Or? 2B? Not 2B, no. It had to be said. Alright.
2B or not?
So 2B, some people say that's terrible. 4, some people say, why the hell did you do that to me, Jeff? Okay. So let's take a look at these. I think the very first major stumbling block for people in calculus is chain rule. You got quotient rule, which people sort of catch on to. Some teachers teach the little song. I teach a song. I don't know if you guys remember the song I taught. No? Top first, and that's the song.
Oh,
yeah.
You get the high, low, yeah, blah, blah, blah. Okay, sorry. So normally people get quotient rule okay, and they get product rule definitely is pretty good, but chain rule is where people just sort of like are like, what the shit? So when I teach it, I try to show why it makes sense before I even talk about it. So for example, let me see if I can remember a good example. If I had this, why do I pick the number 3? It's my worst number. If I had this, and I thought the derivative would work the same as if it was just x to the 3rd power. Are you guys with me? Then I would think that the derivative would be 3 times 3x squared times to the 2nd power, right? And I would think, I'm good. That's the rule we talked about, Mr. Waller, what the shit. Now, what does that become if I simplify this? So I get 9 times 3 is 27. Is that cool? X squared is x to the 4th? Okay. Now, what is this if I simplify this? What is 3x squared cubed? What's 3 cubed? 27. And what's x squared cubed? I like the 8, but be careful. Right? Multiply powers. 3 groups of 2. Let me make sure you guys can see what I'm writing. Even if you can't read what I'm writing, I want you to at least see it. So this was what we thought. And I really want you with me. Do you understand what I'm trying to do? I'm saying, okay, let me try the rule we learned. Bring the power down, power goes down by 1. Why is that not true? Because the function I'm given is this. That is the same, those are the same things, yes? So whatever the derivative of this is, it better equal what I thought it was, or else what I did is incorrect, right? So far, you're not correct. Okay. So if I take this guy's derivative, you rewrite it here. What do we get? This is the correct derivative. Yeah, 6 times 27, which is again, what is it? 42. 6 times 27, right? So 162, thank you. X to the 5th. And these are obviously not the same. But notice, look at the inside of this guy. What's the derivative? Let me call the inside just I of x for inside. There we go, Jeff. That's the inside of it, right? What's this guy's derivative? 6x. And what is 6x, the derivative of the inside, times what I did?
Yeah.
Is that freaking the same answer, right? So I like to do that first to kind of build a bit of a foundation for why I can't assume the rule we learned before will work even if the inside is more complicated. So I like to think of this as a series of gears. What's a derivative tell you? I'll take what you got. Give me. What's a derivative tell you?
Rate of change.
I heard a word slope, right? Rate of change, right? So isn't a slope kind of like a speed? If you're talking about kinematics, all right? So I think of this as gears. If I have a series of gears, there could be one big gear, but then there could be little smaller gears that are a part of that bigger thing. So I have to kind of consider all the parts to talk about like the speed of the whole thing. So this is telling me when I have a function where the inside is more complicated than just x, it speed has to come into play also. I can't just ignore that gear. So what this is saying is, if I try to do this without simplifying it first, the correct way to do it would be with chain rule, which chain rule just says, pretend like the inside is just x. Stuff to the third power. The 3 would come down, stuff would now be to the second power, right? That's the rule we all know and love. 3 times stuff to the second power. Holy shit, what just happened? That was exciting. Okay. It just goes along with the theme of today. Now, we know that's wrong, and what we haven't done yet is to include, to make the chain, of course, the links are multiplication. What's the inside's derivative?
6x.
Yeah, so the derivative of the inside, 6x. And then, of course, if you do all that stuff, we get the right answer. Right? Now, of course, my students know my mantra. When I ask you to do a derivative or an integral of a function, what's the very first thing you look for? If I ask you to do integral or the derivative of a function, I give it to you. What's the very first thing you look for? Where's my former students? Very first thing you try to do. Simplify the damn thing. If I can simplify what I'm asked to do something with, yes, right? I don't like the shit you gave me, but I can simplify it. Oh, just like part C on the thing, I think. Yeah, we'll get it. All right, so coming back to this first dude. All right. Now that wasn't a complete lecture on chain rule, so I'm sorry, it's not going to happen. But I do have a little handout that I gave out to my 180. I'm going to give you in a minute about chain rule. Okay, it's got some examples and so forth. Because I know it gets a little weird for people. What's the very first thing I should do with this?
Exponent to the 1/5.
Yes. In fact, if you're my student, you will hear me say, I wish we would have never created radical notation. It's one of the most foolish creations we ever made. It exists now, too bad for us. A 1/5 power makes so much more immediate sense than a 5th root. Sorry, I have a few opinions. So to take the derivative, I got stuff to the 1/5. So how do I do stuff to the 1/5? The 1/5 comes down. Stuff is now going to be to the what?
-4/5.
Yes, and do you guys know the shortcut? When you're trying to subtract one from a fraction, you just take the numerator minus the denominator and put that back over the denominator. 1 minus 5 is -4 over 5. That works no matter what. If you ever try to subtract 1 from any fraction, you can do what I just did. It's crazy. So 1/5 comes down. Stuff is now to a -4/5 power. But then, of course, what kind of comes into play? Chain rule. So what's the derivative of the inside? 1 minus
6e to the 2.
All right, so you can do 3e to the 2t times 2. Where'd the 2 come from?
The exponent.
Another freaking chain rule, because what's inside the e function?
2 to the 2.
And when I say inside, you guys understand? Because it's e to something. So the inside of an e is the to the part. And inside the e is more than just t. So chain rule goes, I'm with you, right? Are you guys okay? So this will be 6e to the 2t, because it's 3e to the 2t times 2, because the derivative of 2t is 2. And then you could bring that down and whatever, it doesn't matter. Right? Sometimes you're going to have to, if there's something really obvious that should simplify, but this, if you left it like this, I'd be fine with it. It's not much that's going to happen, right? It's not very exciting. Bring that down and put that over, who cares? Nothing really happens. If stuff cancels, then do that. Everybody cool with that first one? Because I know a few people are looking at me like, that first one, man, that's my nemesis. Okay. All right. I like how much room I'm taking. This next one should be an easy one. It's easy or it's the hardest thing in the world because it's just a straight up memorization. Who remembers how to do these exponential? Yes, so it's a to the x is a to the x times natural log of a. So why is e to the x its own derivative? Because natural log of e is 1. So I look at the natural log as an adjustment because it isn't e. E is the only one who's perfectly lined up with itself. Its own slope fits right on top of it. Anything else needs an adjustment to fit on top of itself, right? Okay. Maybe. Now this one, I am not going to do quotient rule, although you could. Maybe I should, because I don't think I have another quotient rule. So let's do quotient rule real quick. How does quotient rule work? My song is first. I really want this to make sense. The whole song, real quick. My philosophy about songs and all this kind of shit is, the more we give you those, the more you believe you need them. Does that make any sense? Like FOIL. Remember FOIL? What is FOIL all about? Do you need that shit? Do you need it? If I write x minus 2 times x minus 3, are you actually going first, out? No. You distribute the x, and then you distribute the other. It's just repeated distribution. I don't need a song or a saying like every good boy does fine. Anybody knows that one? No? Okay. No musicians. Okay. So, with all that said, x minus 1, if I brought it up, what power would it be to? If I brought the x minus 1 up, it'd be to a negative 1 power, right? Because it would be down. So if I brought it up, isn't that a product rule then? So when I do the derivative of the x minus 1 piece, won't it have a minus sign with it because the negative 1 would come out? So when in the quotient rule, it's almost the same as product rule, except the part where I do the derivative at the bottom is negative because it has a negative power on it. Yes? Maybe? Does that make sense? So it's not high-low crap. It's just, I'm going to do this because it makes sense. So my song again is top first. So what's the derivative of the top? 2x minus 3 times the bottom minus the top, that's my third puberty, times the derivative of the bottom. What's the derivative of the bottom? 1, kick ass. All over the bottom squared. And again, there's a shortcut to this, so if you did a shortcut, then test. But I just want to do this because I didn't have another quotient rule, I don't think. And then here I get 2x squared minus 3 minus 2 minus 5x plus 3 minus x squared plus 3x minus 2. Oh, blah, blah, blah. So then I get x squared minus 2x plus 1 over x minus 1 squared, and that's just 1, because those are the same thing. Now, who did something that made that a lot easier? Yes?
You can factor it.
If you factor the top, you get what?
X minus 2 and x minus 1.
So the x minus 1's cancel.
Yeah.
The derivative of x minus 2 is 1. Done. So dear God, if you can simplify stuff to begin with, do that. Why make it so hard? Okay, I like it, right? I try not to give you too many problems where it's like, oh, if you would have just realized, ha ha ha, because that's evil. Because if you don't realize it, then the test takes way long. But I will give you every now and again, I'll give you a little, if you notice it, it would have been a little bit quicker, but it's not going to kill you if it didn't. You guys with me? Okay. This one doesn't need much space. This one's evil. I agree with you that this is evil. So I'm giving it to you now when it's not worth any points. So the answer is not 2 pi, because pi is not a what?
Variable.
Variable. Pi squared is a constant. It's a little more than 9. It's probably 10 points. I don't know what the hell it is. So what's the derivative of any constant?
0.
Freaking 0. I love it. So again, slope. I'm sorry. Instead of slope, what does the derivative tell you? Rate of change with respect to x. So how much is this changing as x changes? This doesn't give a shit about x. It's not affected by x at all. So of course the rate of change is 0. Okay, maybe. Bam. Now again, I don't put like a ton of those, but every now and again I might put something a little bit like that. Right? You just gotta stop and think what you're doing. Okay. So pretty cool, that first 4. Anything from that first 4? Okay. What about this guy? This first integral. Is that a difficult one? No, that's the one you're like, give me these, Jack. Give me these, please, dear God. Right? The worst thing about this is, if I would have given it like this, oh God, Jeff, if I would have written so you can read it, I always get somebody who says this. Is that right? So this person latched on to the natural thing and said, oh, 1 over anything is natural log of that thing. No. What's the only thing that becomes natural log? 1 over x. 1 over x squared is a different power. It follows that general rule. So this is crap, right? So please, dear God, don't write it down as if it's true. Die! Okay, so what does this actually become? Yeah, so the opposite of the derivative rule. The power goes up by 1, and you divide by the new power. So you in derivatives, you multiply by the old power, and it goes down by 1. Integration does all that in reverse, because in wow, integration is the antiderivative. I like it. So it goes to, the power goes to -1. I divide by -1. And then, of course, the 3 just becomes, yeah, it's the one thing that Spurgeon got right. And then, of course, the plus c is nice, too. Now, I did help somebody out with part B. I helped them a little bit, but anybody else get part B? I'm trying to make it a little obvious about the 3. See how they're both 3?
Yeah.
Can't you take a 3 out? All right, do that. You should be left with something that's hopefully semi-obvious at least. Yes? So you get 3 integral tan squared plus 1. And what's tan squared plus 1? Secant squared. And I just want to be a little careful right now. We all understand that without x or something inside of a tangent or a secant, it makes no sense. You guys with me? So when I say integral tangent squared is secant, integral secant squared is tangent. We all know that it's of x. It's got to have something inside of it to make any sense. Okay, good. So I rewrite this as secant squared because that's what that is. And then the integral of secant squared is tangent because the derivative tangent is secant squared. Big hands. So again, those trig identities, they will come into play. C is a lot like D up here, right? Integral of constant dt is just what? Pi t plus c. All right. I'm going to get a clean sheet of paper for part D. That's, yeah. Is that cool, you guys? Pi t plus c is according to t. Integral of any constant, you just add a t on there. I like it. Okay. By the way, I just want to say something real quick. 2 things. If I'm going too fast, slow me down. I'll say 3 things. If I'm going too slow, deal with it. And today is weird because we have a lot of review to kind of do. It's going to be a little hectic. Every day is not going to be like this, right? We're going to go topic by topic. Today's a little, like this, right? It's got a lot of little topics. I'm just trying to get the rush shaken off, right? Okay. So look at D. I think everybody figured out, at least that I talked to, the method you should use. But some people weren't sure how to apply it correctly. So what method should I use? Use sub. What's in there that if it wasn't there, well, actually, why does U sub work here? Let me ask it like that. That's a better way to ask. Why does U sub work? Beautiful. The derivative of a piece of it is in the integral also. And when I'm thinking about will U sub work, I don't give a shit about constants. The derivative of y squared is y. Is that true?
Yeah.
No, think about what I just said. The derivative of y squared is y. Is that true? No. But again, do we care about constants? Any constant I'm missing, I can make it happen. I need a 3, I just put a 1/3 out. I can always play with, they can go in and out, right? Because what does that mean, this symbol? What does that mean, this big freaking S thing? Sum, infinite sum, remember? And can't I factor shit out, a constant out of any house size sum? So that's why constants can go in and out all day. So I don't care about constants. There's a y squared stuck, its derivative is basically y, and that's in there too. So I know U sub will work. So now the question is, what do I let U equal? Some people let U equal y squared. And that I would argue is not exactly the greatest thing. You can still do it, it's not that hard, but
2y squared.
yeah, just make it the whole exponent.
Because then that's where that 4y comes
Beautiful, for a couple reasons. The 4 is going to come out of there. It would be great to have an e to a thing, and that's it. Because e to a thing, e to a variable, kicks so much ass. Integral, derivative, give it to me, right? And I have control over whether I let u equal. As long as I can find the du for whatever u, I'm golden. So let me make it something's going to help me out the most. Shabbat. So what's du? 4y dy. Now, I'm not going to be able to do much about the fact, holy shit, that it's 7:10. But I also can't do much about the fact that some of your teachers taught you to solve for dy. That is really bad, because then people do things that are not really allowed, and it sometimes leads you down ways that won't work, and then you think it works, and it's terrible. But if you've done it, you've had no problem so far, okay, keep doing it, I guess. But it's so much better just to build what you need. It's not that difficult. And here I don't have to build shit. Do I have a 4y in there? Do I have a 4y dy in there?
Yeah.
Yep. So I can replace 4y dy with du. Bam, bam. So that just becomes du. E to the 2y squared becomes e to the u. And the integral e to the u is e to the u. And e and u was 2y squared. And how do you check that? Take its derivative, exactly. If you integrate something, you check it by doing the derivative and making sure it goes back. I like it. Well, damn it. I've reached too far. I'll tell you this. All right, I can't let you out of here without a little new stuff. I just can't. So what I'm going to do, I'm going to do this one and this one. I'm going to do it next time. We're going to do just like a little something from section 7.1, right? I can't. I will definitely do those tomorrow. We are going to do one little thing from section 7.1, and then we're going to head out. Okay? This is way too close. Okay. That might work, especially if you get out of the way. All right. Actually, it's better over here. All my time is going to be setting up the freaking camera. Okay. Way to manage your time, Jeff. Be quiet, Jeff. All right.
We did 725.
And the nice thing is, it's not an iPhone. What's up? Are you? Good try. I like that. It's Android with Gorilla Glass, so it's. I'm not going to try to break it, but I've dropped it so many times and it's fine. Whereas iPhone, you look at it wrong, it breaks. Okay. Now, somebody remind me, what is the product rule? Somehow this applies to the very first thing we do in 7.1.
Times x, n minus 1.
So if I have this, if I have a function that is a product of two functions.
Yeah, I was thinking.
I know what you're thinking about. It's okay. Then the derivative of that is going to be what now?
F of x times
F prime times g plus f g prime. I like it. Now, let me do a couple things. So let me do. No, it's fine. It's fine. Let me let. You can do it, Jeff. What do you want to do? Let f of x be u. Let g of x be v. You guys kind of with me? So what this says is, this is neat. What this becomes, somehow this is going to become an integral thing. This becomes, only write this, f of x, g of x, prime equals f prime g plus g prime f. Let me just do it quickly like that. Is it cool? So, therefore, u times v, let me do this. D by dx, u times v, equals v times du dx plus u times dv dx. I really want you to follow. So if I call f, I'm just going to call it u. I'm going to call f u. And I love it. You're all like, why? Why? Just because. Are you guys all with me? Ultraviolet, exactly.
My teacher, old teacher made an acronym for
Yes.
ultraviolet voodoo.
Yes. What ultraviolet voodoo, right? Yes. Okay. So you see where I'm going. All right. Now here's the trick. Do you guys see how they all have dx's on the bottom?
Mm-hmm.
All right. So let me just kill those. Die. I can just multiply those by. So now I've got du times v equals v du plus u dv. Yes? Let me stop for a minute. Does everybody see every step here? We all know product rule. Product rule is awesome. Give me product rule, Jeff. Yes. Right? So that's where we started. So I basically just captured what we had here, there. Then I called this u and this v. So f prime is du dx, yes? Because I called f u. So now everything's got a dx, I can kill them. Just multiply by dx, it's gone. So now I can integrate. And I love it. You're all out there going, sure, I can. Why the hell would I want to? So hopefully I can get to a point where I can show you an example. Am I? Maybe. So what do we have here? What's the, and now this is weird. Help me out. What's the integral dx? X plus c, right? What's the integral, screw it. What's integral dm? M plus c. So what's integral du times v? Frickin'. What's the idea? Whatever I put here, it's there. M, u times v. U times v plus c. I like uv plus c. So when I integrate this, I get u, the equals, uv equals this. And I know right now somebody's out there going, that's, okay. Yay, Jeff. We're almost there. So here's the powerful step. And this, again, you're not even going to know this is the powerful step. If I solve for this, isn't this just this? Yeah. No. Without a concrete example, this is all shit. You guys agree? You're all like U's and V's and F's and G's and what you do, you just did a lot of shit. Can you kind of follow what I did? Can you kind of, every step kind of follows, right? Now let's really see what the hell, why this is good. Let's do a very basic example. And then we'll get out of here. Okay. This is a really basic example because it just feels like it should be easy. And no, the answer is not 1 over x because that is the what of natural log of x? The derivative. So what the shit's the integral? Now, if you know it, be quiet. Some of you guys have had some calc 2 before. I don't want to hear. But there, can you see how we don't currently have any? Will u sub help? No. U sub ain't gonna do shit for us here, right? Yes. So we're like, I don't know. And it feels like it should be not that terrible, right? So, what this says is if you can identify a function and the derivative of a function. So this isn't quite like u sub. It sort of feels like it is, but it's not quite. Every piece of the integral has to belong to u or it has to belong to dv. So go. I don't want to call, so the whole idea, do you see how, so this is this. This is a way to rewrite it, and I'm hoping that when I rewrite it, I get an integral that I can do. Careful, no? I think maybe you said that right. Say it again.
We have u equals ln x.
Good.
V equals
dv.
Or dv equals
equals dx. So do you see how this? So if you could either have been this, or you could have been this. You could pick which one. Now again, how much have we worked with this so far? Oh, a little over a minute. So we don't know yet how this fully works yet. I'm just laying some ground rules. Every piece of the integral has to either be u or dv, and then it matches this form, yes? This is integral u dv if I call that u and I call that dv. So what good does this do me? Well, what's this require me to know? I need to know what u is and what v is. Do I know what u is?
Yes.
Yes. Do I know what v is?
Yeah.
No.
No.
dv is dx.
Yeah.
The derivative of v is the derivative of x, so what is v?
X.
Freaking x. Yes. Don't worry about the plus c business yet. I'll show you why you don't have to worry about that at the moment. Right? Do I need something else? du. Yes? What's du?
1 over x. 1 over.
1 over x dx. Yes? So let's see what this tells me then. This equals u times v. Are you guys with me? Do you guys see if you can figure out, and that's one thing we're going to do, is just tell me how to figure out what the hell's u and what the hell's dv. Because then once you get those figured out, it's just plugging shit in. If you know u, you know du. If you know dv, you can integrate to get v. And then you just plug shit in. Now the bad part is if you get an integral here that's worse or the same, because you want something that's better. Yeah? So let's see. Minus what it goes in here. V, what's v?
X times 1 over x.
Yeah. X and du is 1 over x dx. And that kicks so much ass, yes?
Because it's just
Because the x's cancel. What's the integral of 1?
x.
X. And now you can put your plus c. So why didn't you have to worry about your plus c right here? Because there's still an integral that can capture all the constants. You guys follow? Now again, how much have we worked with this? Not even 5 minutes, so you don't know everything there is to know. But you kind of get what it's trying to do. And there ain't no way in hell you could have done this integral in 180. And now we've got this crazy powerful, and this is called by parts, which makes sense because you're breaking the integral up into these identifiable parts. And I'm sorry, I wanted to let us out early, and I ended up letting us late. Too bad. So I will put the video up. It'll be up by tomorrow, so if you want to look at it for whatever reason. If you need to add, come up and see me. If you have any questions, come up and see me. Otherwise, I will see you guys Wednesday.
I have a question that's more related to the definitive thing. Is there like going to be, can I like kind of lock in